First, we will get opening from MC, and then we're gonna pray, and then national anthem of Indonesia Raya and Mars Satya Wacana, and then opening speech from Deputy of Dean Kristiawan Prasetyo Agung Nugroho, and then photo session together, and we will taking from Rindu, and then the international mini conference anti-inflammatory effects of blackberry, phenolic, and volatiles. My moderator as Mrs. Karina Bianca, and then Mr. Luke as a speaker. And then Q&A, and then closing. Okay, before we start, we will pray first before we starting the conference. I will lead the pray. Come on, let's go. We will pray. I will lead the pray. Dear Lord, thank you for your blessing today until now. In the middle of pandemic, you still give us blessing for the healthiness and still doing the research for us, our faculty. Thank you for today. Because of your blessing, we can join together in this conference. Give bless for Professor Luke Howard, who will give a conference today. And the last, I hope you will with us from start in the end of the conference. Thank you, Jesus. Amen.
Amen.
Amen. And now, national anthem of Indonesia Raya and Mars Satya Wacana. Please, house can opening the song. And now, Mars Satya Wacana, please, host. Halo.
Satya Wacana, hiduplah garba ilmiah kita, mengabdi Tuhan, gereja dan bangsa, proklamasikan kerajaan surga, bela keadilan, bela kebenaran, pantang mundur maju perkasa, bela negara, hamba Allahnya, amalkan hikmat Pancasila. Satya Wacana, Satya Wacana,
Thank you. And now there is a opening speech from Mr. Kristiawan Prasetyo Agung Nugroho. Please, Mr. Kristiawan.
Yeah, okay, thank you, Pak Pulung. Yeah, good evening, seminar participants who are pleased to be able to participate virtually at the International Mini Seminar on Anti-Inflammatory Effects of Blackberry Phenolics and Volatiles. And also, good morning, Professor Luke Howard from the Food Science Department, University of Arkansas. And I'm here to greet the participants of the International Mini Seminar and also Professor Luke Howard as our speaker on behalf of the Dean of the Faculty of Medicine and Health Science, Universitas Krishna Satya Wacana. Yeah, thank you, Professor Luke, for being able to visit Indonesia virtually during this pandemic era to share information and also knowledge with us. And we are delighted that Professor Luke Howard can share his experience and his expertise on health-related topics with us. And for your information that our university is located in Salatiga in Indonesia on the island of Java in the province of Central Java. And Salatiga is a little city in comparison to Jakarta as our country stated. Yeah, and hopefully you will be able to visit Indonesia and especially to Salatiga one day. And we can meet and greet together with us. And we also have 4 study programs. The first one is nursing study programs, and then nutrition study program, physical education, health and recreation study program, and the newest or the youngest is food technology study program. Yeah, even food technology study program is the newest or the youngest, but it has already achieved many breakthroughs in the fields of education, both from the lecturers and also from the students. And our theme discussed for tonight in this session are relevant to our current works in the health sector. And yeah, Indonesia still continues to struggle with a variety of infection and also non-communicable disease. And yeah, inflammation, as in diabetic or other metabolic disease, is one of the clinical signs. And hopefully, this topic will be able to expand our understanding and also our knowledge of nutrition and chemical aspect, as well as the potential for biodiversity in Indonesia to benefit. Yeah, we hope that in this short time, we can learn a lot from Professor Luke Howard. And then, yeah, finally, yeah, I'd like to express my gratitude to Professor Luke Howard and for the International Mini Seminar attendees. And yeah, thank you for your time and consideration, and have a pleasant evening. Yeah, thank you.
Thank you.
Thank you, Mr. Chris. Okay, and now we have a photo sessions, and Rindu will taking a picture. Are you ready, Rindu, for taking a picture for us?
Sure.
Maybe audience can opening our camera. Your camera open, all camera. Yes. We have a photo together, taking a picture together. Are you ready, Rindu?
Ready.
You have to comment us 1, 2, 3, okay?
Okay,
Rindu?
ready, sir.
1, 2, 3. Please comment us, okay? Give a comment.
All right. 1, 2, 3.
Okay.
So much page.
1, 2, 3, slide 1. Next, slide 2. Okay, 1, 2, 3. Next, slide 3. 1, 2, 3. Okay.
Finish?
Well done.
Okay.
So,
Are you done? Okay, thank you, Rindu. Okay, now the session that we're waiting, the International Mini Conference, Anti-Inflammatory Effects of Blackberry, Phenolic and Volatile. And this conference will lead by Mrs. Karina Pianka-Lewarisa as a moderator. Please, Mrs. Karina, you can start the conference now. Please, thank you.
Okay, thank you, Pak Pulung.
Yes.
Good evening, everyone. Good morning, Dr. Howard. Thank you all for finding time and visiting today's webinar. I'm Karina. I'm the moderator of today's webinar. And I'm very pleased to see you here and welcome all of you. Today's seminar is about anti-inflammatory of blackberry phenolic and volatiles. And we have our distinguished speaker, Dr. Luke Howard from University of Arkansas. So let me introduce Dr. Luke Howard. Dr. Luke Howard received his BS degree in horticulture from Purdue University and his MS and PhD degree in food science from the University of Arkansas. He has served on the faculty in the Department of Food Science at the University of Arkansas since 1997. And his research program is focused on extraction and characterization of bioactive compounds in fresh and processed fruits and vegetables. And Dr. Howard has published over 140 articles and 5 book chapters and has delivered over 100 presentations at scientific meetings. So before we begin this presentation, let me inform how the presentation will going on. So first, Dr. Luke Howard will deliver his presentation, and then after that, there will be question and answer session, and then followed by the conclusion. So now allow me to welcome our distinguished speaker, Dr. Luke Howard, to deliver his presentation. So Dr. Luke Howard, the floor is yours and the time is approximately like 55 minutes. Okay, thank you.
All right. Thank you very much, Karina, and thank you so much, everyone, for the warm welcome and introduction. It's a pleasure to give my presentation early for me, but late for you. It's just wonderful with technology that we could actually do something like this. So how will this work? Do I need to share my presentation?
Yes, you can, I think.
Okay, so let's, okay. Yeah. Wait a minute. Oh. Messed up already. Let's see, I've got to go. How do I stop the share? I got to pull it up here first. Here we go. Okay, now let's try sharing. There we go. All right. Okay, can everybody see the presentation?
Yes.
Yeah.
Okay,
Yes,
perfectly. So yeah, what I'd like to do today is share some of the recent results we've done working on berry volatiles. All the health benefits associated with berries are thought to be due to the polyphenolic compounds that are present in berries. So what we've done over the past 5 years is looked at anti-inflammatory properties of these volatile compounds that give berries their characteristic aroma. So when we look at the phytochemicals in berries or any fruit and vegetable, there's a diverse array of compounds. First of all, and a lot of times we ignore the dietary fiber of fruits and vegetables that are very important. We have antioxidant vitamins like vitamin C or ascorbic acid, vitamin A, a little bit of vitamin E, plus B vitamins. Then we have the carotenoids that, of course, are the pigments in vegetables and fruits. And the fruits and vegetables are rich in phenolic compounds, and especially berries. So if you look at the color of berries, each berry has a unique color, right? And very dark, intense color. That means it's high in anthocyanin pigments, which is going to equate to a very high antioxidant capacity as well as anti-inflammatory properties. So whenever we see a ranking of fruits and vegetables based on antioxidant capacity, berries typically come out at the top or right at the top due to the high level of anthocyanin pigments. So we all know we're supposed to eat our berries as part of the 5-a-day program where we eat 5 servings of fruits and or vegetables a day. Now, what about inflammation? Inflammation is the body's response to harmful stimuli, such as microorganisms or an injury. Unfortunately, the Western diet that we have in the US, which is high in carbohydrates and fat, also leads to acute and chronic inflammation, as well as oxidative stress. So the inflammation mechanism starts with the intervention of immune cells, such as the neutrophils, monocytes, macrophages, or mast cells around the site of inflammation. And then these immune cells release what we call inflammatory cytokines, such as TNF-alpha, IL-6, and IL-10. And then these cytokines themselves release inflammatory markers such as nitric oxide, prostaglandins, and these markers create an amplified inflammatory situation. Now, NF-kappa B is able to regulate the expression of cytokines, and if these are overexpressed or if the inflammation does not resolve, then there's a situation of chronic inflammation that can contribute to the initiation and promotion of a whole host of chronic diseases such as cancer, asthma, cardiovascular disease, neurological disorders, etc., including metabolic syndrome. So we definitely need to control inflammation in the body in order to afford protection against a number of different chronic diseases. Now, as I mentioned before, almost all of the work on health benefits of fruits and vegetables, including berries, has focused on phenolic compounds because fruits and vegetables are rich in phenolic compounds, but we've got a wide array of different phenolic compounds present in fruits and vegetables. Most of the work has focused on anthocyanins and then quite a bit on tannins, procyanidins, condensed tannins, or hydrolyzable tannins such as elagitannins. So the compounds we've been working with the last several years are terpenoid compounds, okay? There's actually quite a bit of literature in the essential oil field that shows that terpenoids are very good anti-inflammatory agents. So in our research, we started looking at these terpenoid compounds for their ability to inhibit inflammation in berries. So first of all, the phenolic compounds, you're probably all familiar with phenolic compounds, but we have a phenolic ring here that has hydroxyl groups. So we can have simple phenolic compounds with just one phenolic ring. Any compound that has a phenolic ring with a hydroxyl group can donate a hydrogen atom or electron to a free radical to thus stabilize it. So all fruits and vegetables contain phenolic compounds, so they have high antioxidant capacity. The more phenolic compounds you have, the higher the antioxidant capacity. Phenolic compounds are complex. We have many different classes of phenolic compounds. So we can have hydroxybenzoic acids that have a very simple structure. Then we get the hydroxycinnamic acids. One of the common ones is chlorogenic acid that's present in very high amounts in blueberries. And of course, I get mine through my coffee consumption. Then we can get the flavonoid structure. Okay, a more complex structure. There's a number of different flavonoids, as you can see examples here. So we have two phenolic rings and then a heterocyclic middle ring here. So among the flavonoids, the most widely studied are the anthocyanins, because these are the compounds that impart the color to fruits and vegetables and are so high in berries. We also have the flavanols, so the simple monomers, catechin, epicatechin. These can polymerize to form large procyanidin compounds called tannins. And then we also have stilbenes. You hear a lot about resveratrol in grapes and its anti-cancer properties, but it's present at a very low concentration. So the bottom line with phenolic compounds is all plants contain phenolic compounds. but it's important to know the composition and the amounts of individual compounds because each one has a different structure. Even the anthocyanins have different constituents at the R1 group or R2 group, which can influence their antioxidant capacity and anti-inflammatory activity. For example, delphinidin, you can see at R1 and R2 has hydroxyl groups. The more hydroxyl groups on this B ring, the higher the antioxidant capacity. So the structure of the compound is very important in terms of bioactivity. So what are volatile compounds? First of all, the best way to think of volatile compounds is these are the compounds that are responsible for the aroma of the fruit. So I'm pretty sure I could put a blindfold on you and have you smell a strawberry and you would know right away from the aroma that that's a strawberry. So these compounds are odor active at very low concentrations, typically less than 10 parts per million or micrograms per mil. We get a very strong odor. So that'll be important later on when we talk about anti-inflammatory activity, because even though they're present in the berries at a very low concentration, they still possess potent anti-inflammatory activity. So why are they volatile? They have a low molecular weight and they have a high vapor pressure. Now, we measure these volatile compounds by gas chromatography, okay? Because they're nonpolar and they have a high vapor pressure. So you can see here, this is actually a GC chromatogram for blackberries. So it's very complex. In many cases, we'll get over 100 different peaks that contribute to the aroma of blackberries. Now, a lot of times when we look at a chromatogram, we think, ooh, these high peaks, as you see here, might be responsible for the aroma. But in many cases, it's a very little bitty peak here that has a very strong aroma impact. So each one of these individual compounds has a different smell or aroma, but then we mix them all together, then we have the characteristic blackberry aroma. So volatiles and aroma. So when we smell these compounds, okay, we detect these in the olfactory bulb, the nasal cavity. Okay, since they are volatile, they go directly to the nose, olfactory bulb, and this sends a sensation to the brain that lets us say, yes, this smells like a strawberry or a blackberry. Look at all the different aromatics that we get with these different structures. So here we have an aldehyde, benzaldehyde, which gives us an almond sensation. Limonene, okay, a monoterpene gives us citrus. Linalool, also a monoterpene, gives us flowery. Alpha terpineol, another monoterpene, gives us a nice lilac aroma. Hexanol, an alcohol, gives us a fatty or fruity type of sensation. Ethyl butanoate, an ester, gives a fruity or cognac. Beta ionone, okay, which is a C13 norisoprenoid. This is a breakdown product of carotenoids, and that gives us a very nice violet aroma. And then raspberry ketone, which is, of course, a ketone, as you can see here with the ketone function, gives us a sweet berry or floral aroma. Now, these berry volatiles are collected when we make a berry juice. During the evaporation process, we collect these volatile compounds, and they're actually sold as natural blueberry or berry flavor as an essence. So we can add this natural flavor to a number of different food products, okay, such as drugs and nutraceuticals, confectionaries, essential oils, perfumes, cosmetics, even biofuels. So these terpenes play an important role in plants to help deter against insects and birds, rodents, okay? Due to their strong aroma, they will repel insects and predators. So this is interesting because we're already using natural flavors in a number of different food products. and pharmaceutical products. So if they have health benefits, that's a great thing. So the objectives of this research was firstly to isolate and characterize the polyphenols and volatile compounds in both cranberries and blackberries, and then to compare the antioxidant and anti-inflammatory activities of these polyphenol and volatile fractions from each berry type. So how do we do this? First of all, we extract the phenolics using a tissue miser here with the solvent methanol water formic acid. So we blend that up, get the extract, and then we evaporate the solvent using the speed vac. And then we take that concentrated extract through a solid phase extraction protocol to remove sugars and acids and get more of a purified phenolic fraction. And then again, we evaporate the solvent. So we take the residue back up to the same volume or mass that we started with. So if we start with 5 grams of berries, we take it up to 5 milliliters. So we're at about the same concentration that would be found in the fresh berries. For the volatiles, we blend them with water and salt, sodium chloride, to inhibit enzymes. Okay, and then we do a low temperature vacuum distillation at 50 degrees Celsius. So we collect the volatiles in the aqueous fraction, and then we're ready to go. It's a slight dilution of what's found in the fresh berries since we add water, okay, to extract the volatiles. But we have about 50 to 75% of the volatiles that are found in the fresh berries. So what we're trying to do is actually compare the concentrations of the phenolics and the volatiles as close as possible to what's found in the fresh berries. So to analyze the volatile compounds, okay, we use solid phase micro extraction. So we have the spemy fiber that we put into the headspace of the sample. Okay, so we heat it for 60 degrees Celsius. The volatile compounds are absorbed onto the spemy fiber, and then this is injected into the gas chromatograph. So then we get these large number of volatile compounds that we can identify by gas chromatography and identify by gas chromatography mass spectrometry. So first of all, let's look at cranberry results. Cranberries are unique. I've had the privilege of visiting a cranberry bog up in Wisconsin. So it's the most unique harvesting method because the cranberries aren't grown in water, okay? They're in the bog, but when it's time to harvest, we flood the bog with water, and you can see this tractor here going through. It knocks the cranberries off the plant, and then we corral the cranberries here for the harvest. So it's a very unique harvesting system. So I had the student look at, first of all, here, antioxidant activity of different berry extracts. And from the literature, any berry with high levels of anthocyanins has high antioxidant capacity. So you see the black raspberries, blackberry, cranberries. This is the phenolic, even strawberry, red raspberry, blackberry. Now look at the different units. If we look at the antioxidant capacity of the volatiles, this is micromoles of Trolox equivalents per liter, whereas the phenolics are micromoles, okay, per mil, not liter. So the antioxidant capacity of the volatile fraction is very low, okay, compared to the phenolic fraction. And that makes sense because the volatiles are present in the berries at a much lower concentration than the phenolic compounds. So we wanted to look at the phenolic and volatile fractions from cranberries. So this was published in 2019 in Food and Function. So Katie Moore did an interesting study where she looked at the volatile and phenolic extracts as a preventive treatment. So we treated the raw cells with the extracts before inducing inflammation with the lipopolysaccharide, or we treated with the lipopolysaccharide and then treated the cells with volatile and phenolic extracts as a mitigative or curative treatment. Now, look at the concentrations of the phenolic and volatile fractions. Okay, the phenolic fraction, 636 parts per million, the volatile fraction, only 1.8 part per million. So the phenolic extract is 353 times more concentrated than the volatile extract. So here we looked at the ability of these fractions to inhibit the production of nitric oxide. So let's look at those results. So we look at the ability to inhibit nitric oxide. So when we challenge with the LPS, we get a large increase in nitric oxide. So we've induced inflammation in the raw cells. So the volatile fraction, and this is close to what's found in the fresh berries, at 1.8 micrograms per gram or ppm, work just as well as the phenolic fraction at 636 ppm. And so we do the dose response, even diluted twofold, we still get a significant inhibition of nitric oxide, and the same way with the phenolic fraction. Okay, so since this was applied before applying LPS, this indicates a preventive effect of both the volatile and the phenolic fractions. Now let's look at the mitigative or curative effect, okay, where we apply these extracts after we induce inflammation with LPS. We see the same story. The volatile fraction at only 1.8 ppm works just as well as the phenolic fraction at 636 ppm. So the volatiles work just as well as the phenolics, even though they're present in the berries at a much lower concentration. Now, the next thing we did is, okay, we identified the volatile compounds in the volatile fraction from the cranberries. What were the major volatiles? And we found that alpha terpeneol, okay, a monoterpene, was the major volatile. So we looked at these compounds at the same concentrations found in the fresh berries, and we found the major volatile alpha terpeneol gave us, again, a 50% reduction in NO concentration, okay, which was similar to the volatile extract. These other volatiles did not work significantly, but look at how low the concentrations are of the linalool oxide, eucalyptol linalool, okay? So we think most of this anti-inflammatory activity is due to alpha terpeneol. So this was the preventive treatment, and then here's the curative treatment. So again, we see the same thing. The alpha terpeneol standard at the same concentration found in the fresh cranberries is able to prevent the production of NO about 50%. So it works both as a preventive treatment and as a curative treatment. All right, so let's move on to blackberries. Blackberries are popular in Arkansas, even though the production isn't high. Why are they popular? Because we've got this world-renowned blackberry breeder, Dr. John Clark, that's developed blackberries that are grown all over the world. And he just released one called Ponca, which is the best blackberry I've ever eaten. A problem with blackberries, you get a handful of blackberries and half of them are sweet, and then you get some that are very sour or astringent. The beauty of this blackberry is over 90% of them are sweet. They're not sour and not astringent. So in this study, I had my graduate student, let's see, go back. So this is Pauline Morin from France that did this work, and she just recently graduated as working in the food industry. But initially, she screened a number of different advanced breeding lines. So if they have an A number, They haven't been released yet. These are in Dr. Clark's breeding program. And then the ones, Ouachita, Primark, are commercial varieties, Natchez, Cato, Osage. So she screened commercial varieties and advanced breeding lines. We wanted to select 3 varieties that varied markedly in total volatile compounds. So here we're looking at parts per billion. So we selected the ones in blue for the anti-inflammatory study, okay? So A2587 had a very high level, Natchez, intermediate, and A2419 had the lowest level. So we see a 2.3-fold difference in total volatiles among these 3 genotypes. So when we look at the blackberry volatiles by GC, we see that the aldehydes predominate, 44% of total volatiles, and then the esters, 18%, monoterpenes, 16%, alcohols, 10%, acids, 10%, and then very low levels of these other volatile compounds. But we see over 160 compounds in GC chromatograms. So a lot of good chemistry going on in order to identify these compounds and then order a bunch of standards to try and quantify. So if we look at the chemical composition of those 3 selected blackberry genotypes, you can see they vary markedly in total phenolics, also total anthocyanins, and we already saw that the volatile concentrations are markedly different. Okay, so if we look at the difference between total volatiles and total phenolics for A2528, there's 15,000 times higher concentration of phenolics than volatiles for this genotype, almost a 4,000 higher level of phenolics than volatiles, and this one an 8,000 higher level of phenolics than volatiles. Another thing we did with this study is after we identified the major volatile compounds in the blackberry genotypes, we made a mixture using standards of these volatile compounds at the concentration they're found in the blackberries. Okay, so here we have a number of these compounds. Some were present at pretty high concentration, others fairly low. So again, we looked at the anti-inflammatory activity, but now we were looking at different inflammatory markers. Besides nitric oxide, we looked at IL-6 and TNF alpha. So we had the diluted volatile extracts. Since they were present at a low concentration in the berries, we did dilutions of 2-fold, 4-fold, and 8-fold. And then for the phenolic extracts, we did diluted those 10, 20, and 40-fold. So we looked at the preventive treatment where we applied these extracts before treating the cells with LPS to induce inflammation. And then we measured the production of these inflammatory cytokines, nitric oxide, IL-6, and TNF alpha. Now, the first thing we did is we wanted to make sure that our extracts were not cytotoxic, okay? So we looked at the different dilutions on raw cell viability, okay? So we didn't want to see that these extracts reduce cell viability. So at least at the concentrations we were using, none of the treatments, at least at the time we were using 1-hour treatment, you can see the darkest bar, none of those reduce cell viability. So we knew that our extracts were not cytotoxic and that we were good to go in terms of measuring the inflammatory cytokines. So let's look, first of all, at the nitric oxide results, okay? So here's with no LPS added to the cells, so we don't get the production of NO. This is with the challenge with LPS. We get a nice increase in nitric oxide. So here we have the 3 different genotypes, A2528, okay? This is the phenolic fractions, 10, 20, 40x. So all of the phenolic fractions inhibited the production of nitric oxide. This is that same genotype. These are the volatile extracts worked much better than the phenolic fraction at inhibiting NO. And we see that for the next genotype. So we see the same pattern where the volatile extract worked better than the phenolic extract for all three genotypes, okay? Even though these volatiles are present at a much lower concentration, they still inhibit nitric oxide better than the phenolic extracts. So all the phenolic and volatile extracts were less than the positive control. The phenolic extracts at 10x, the most concentrated extract, showed 24 to 42% inhibition, whereas the volatiles at the most concentrated dilution, 2x, showed 51 to 63% inhibition. And then if we looked at that mix of volatile standards, the major compounds found in the volatile extract from the blackberries, they also showed a 59% inhibition. So next we look at the inflammatory marker interleukin-6, and we pretty much see the same result we saw with the nitric oxide, okay, where the volatile fraction works just as well, if not better, than the phenolic extract or fraction. So you look at the phenolic extracts at 10x dilution, we see 35 to 53% inhibition of IL-6, whereas the volatile fraction, we see 34 to 60% inhibition. And this mix of volatile standards was very effective, reduced the IL-6 production by 80%. So again, both the phenolic and volatile extracts inhibit the production of the inflammatory cytokine IL-6. And here the volatiles work just as well as the phenolics. Next, we look at the TNF-alpha results. See pretty much the same thing. Once again here, the volatile extracts work better than the phenolic extracts in inhibiting the production of TNF-alpha. So phenolic extracts at the 10x dilution, we see 28 to 44% inhibition, whereas the volatile extracts at 2x dilution, we see much greater inhibition, 61 to 73%. And this mix of the volatile standards, we see a 75% inhibition of TNF-alpha. Now, one of my colleagues, Dr. Sun-Ok Lee, has also had a graduate student working at the anti-inflammatory effects of volatiles. And in her study, she looked at 6 different berries: blackberries, red raspberries, black raspberries, blueberries, strawberries, and cranberries. So she's pretty much seeing the same thing that we're seeing, but she's also seen that the volatile fractions from these berries can inhibit prostaglandin E2 and cyclooxygenase. And importantly, she's shown that both the phenolic and volatile extracts reduce the nuclear translocation of NF-kappa B by blocking phosphorylation of P65 and degradation of the kappa B. Okay, so every study we've done so far has shown that the volatiles work just as well as the phenolic compounds. So it just shows some of the mechanisms through which these cytokines are formed. So in the previous slide, I said that you block phosphorylation of P65, okay, which would be similar to this pathway. Okay, so if we can do this, then we can block transcription of the formation of these inflammatory cytokines. So we definitely need to do more work in terms of studying the mechanism by which the volatiles inhibit the production of these cytokines. But at least Ina Gu's study indicated that you could block this P65 pathway, okay, which would reduce the transcription and the synthesis of these inflammatory cytokines. Now, another promising thing about volatile compounds is we get rapid absorption of these compounds. So again, they're responsible for the aroma. So a lot of these compounds go directly through the nose into the lungs. So you can get up to 54 to 70% pulmonary absorption of these compounds. That's a big advantage to phenolic compounds that have to be absorbed in the small intestine, and a lot of them are poorly absorbed. But we do know that these volatile compounds also go through phase 2 metabolism. So we're going to be seeing different structures in the body than what the standard compounds look like. So they will get glucuronidated or methylated. So about 60% is excreted through the kidney and 15% through the feces. We definitely need more work with animals and humans on the bioavailability of these volatile compounds. And this is going to be very challenging from an analytical standpoint, because if these compounds are only present in the berries at less than 10 parts per million, it's going to be challenging to measure all of these different metabolites in the plasma or urine. So in conclusions, we know that berries contain a complex mixture of volatiles. Each berry has a different profile of volatiles. That's why they all smell different. We have shown that berry volatiles have comparable or better anti-inflammatory activities as the polyphenols, even though they're present in the berries at a much lower concentration. Interestingly, the total volatile content of the blackberry genotypes, so they varied almost threefold in total volatiles, but they all had comparable anti-inflammatory activity. So it may be that the composition of the volatiles is more important than the total concentration of the volatiles. But as I mentioned in the last slide, we definitely need to do some studies using animals or humans to determine the bioavailability of the volatile compounds, identify their mode of action, as well as possible synergistic effects between volatile compounds and the phenolic compounds. Now, one last final slide here, and this is exciting. Unfortunately, we haven't started this because due to COVID, these natural berry essences have been on back order. But in this study, we're going to use human subjects. So we're going to have berry flavored water. So we'll have these natural berry essences added to water. These products are already on the market. So there's different berry flavored waters. Hint is a popular brand because it has no sugar or artificial sweeteners added. It's just natural berry flavor. So in the first part of the study, and we've already done this, we wanted to use a concentrated extract in the water, but we needed to determine what's the rejection threshold, what's the highest concentration we can use before consumers would not drink the water. So we've already identified that. So now, once we commence this study, we will be looking at the bioavailability and anti-inflammatory effects of these volatiles in obese normal weight subjects after they consume the berry flavored water. And in another study, we're going to induce inflammation from exercise heat stress. And so we're going to see if the subjects that consume these berry flavored waters do indeed get a benefit of reduced inflammation. So again, we'll be measuring the inflammatory cytokines in this study in the plasma and urine samples from the human subjects. So my lab crew, since I'm retiring fairly soon, I'm down to a small crew. So there's my technician that is involved in all of these studies, Cindy Brown-Miller, and then the graduate students, Katie Moore, that did the work on the cranberries, is now at dental school at the University of Iowa. And Pauline Marin, that did the blackberry work, graduated and is working in the food industry. And then Laura Lefebvre, both of these girls are from France, is my final graduate student. And she's looking at the anti-inflammatory properties of blueberry volatiles. So with that, I would be happy to entertain any questions you might have.
Thank you, Dr. Howard. It is really a very interesting topic. I mean, it's quite new for me. I think also for all the audience. And I think now we come to the question and answer session. So if you have any questions, you can write down the questions on chat, or you can also raise your hand if you want to speak directly.
Can I ask some question, Miss Karina?
Yes, of course, Kak Pulung.
Okay, thank you, sir. Maybe I will ask some question. One question first. One question about the methods. Sir. Is that a possibility we can take some another method, maybe another simple method that we can use to take phenolic or volatile compounds? Another method, is that possibility we have some another methods?
To measure concentrations or to measure anti-inflammatory activity?
Inflammatory, maybe.
Yeah, that's the problem. You know, antioxidant activity is very simple to measure. All you need is a spectrophotometer. The problem, then the simple answer is no, I don't know of a simple method to measure anti-inflammatory activity. I wish there was one, because cell culture studies are a real pain. They're, you know, the students have to get a lot of training. The cells have to be growing at just the right rate. Okay, it takes a long time to get cell culture results. So no, somebody needs to come up with a good anti-inflammatory method. I'm not aware of one that wouldn't involve the use of cells, because it's expensive to do the studies and it takes a long time, because you've got to have a lot of training time for the students before they actually get good results. Because unfortunately, these are living cells and they die easily. They have to be treated just right. But a lot of times, you know, you do everything right and the cells still grow. So you have to get another batch and passage them. So yeah, I don't recommend cell culture work. If you have the amount of grant money, I would go straight to an animal model. And then you can actually look at the bioavailability of these compounds.
Thank you, sir.
Sure.
Any questions? Maybe Bu Nina?
Not yet, Karina. Interesting. Usually we only anthocyanin and phenolic, only rare about the volatile have bigger effect, good effect on inflammatory, Dr. Howard.
Right. I mean, yeah, it's really exciting work, because everybody thinks the health benefits, and especially the anti-inflammatory effects, are due to the polyphenols, mostly anthocyanins. The fact that these volatile compounds could be playing a role. One of the reasons I think this is exciting is every 2 years we have a berry health benefit symposium, and all of the speakers that are doing the nutrition work, they always talk about, you know, when they look at the phenolic fraction versus the whole effect, that there appears to be other compounds in the berries that are also playing a role. And, you know, after seeing our initial cell culture results, I think it very well could be these volatile compounds. Because we know from the essential oil literature that especially the monoterpenes, do have very potent anti-inflammatory activity. However, you have to keep in mind that our studies are only cell culture, okay? So they don't tell us anything about the absorption or the bioavailability. So it's going to be real interesting when we can actually do that study with the berry flavored water, if we do see anti-inflammatory activity that would be great. But you always have to take cell culture results with a grain of salt or caution, because they don't tell you about absorption or metabolism.
Yeah. Thank you.
Sure. So I guess we need to smell our berries too.
Any questions from the audience? Because I think this is quite new. I mean, the techniques and everything, like the SPME, the way you extract the volatiles, I think it's quite new for our students.
Yeah, the solid phase extraction, it's actually a simple technique, because you just grind up the berries in a vial, and then the solid phase extraction, it's like a needle. It goes down and it's just absorbing the volatiles in the headspace of the volatile in the vial. Okay, so after they've absorbed onto that fiber, you pull it up, take it over, and inject it into the gas chromatograph. So it's actually a pretty simple technique. But yeah, and you need a good gas chromatograph, and ideally one that also is a mass spec, because you got to be able to identify the over 100 compounds. And then also order all those standards. That's taken some time. We probably have 70 or 80 standards, but we don't have standards for the 140 compounds, because it's expensive, and some of those compounds don't have standards available.
Okay, I see.
And the phenolic, you have the same problem with phenolic compounds. There's so many different phenolic compounds. Nobody has all the standards. So it makes it challenging.
Yeah. Expensive.
Inexpensive.
Dr. Howard, I have questions. Do you think there is also possibility to have this kind of things like volatiles from other fruits? I mean, not berries.
Oh yeah, definitely. Because our hypothesis is it's the monoterpenes, because we know this from the essential oil research. But yeah, you think of fruits, I mean, mangoes, all fruits have a high volatile concentration due to the aroma, and each one has a different profile. I mean, we've already measured the volatiles in blueberries, blackberries, red raspberries, black raspberries, cranberry. Each one has a different profile. So no, and I'll bet you've got some great tropical fruit there in Indonesia. That would be, it would be wonderful to test. What's the most popular fruit in Indonesia?
Durian.
Which one?
Durian.
Yeah.
Durian is a fruit that many. The smell is very strong.
Yeah.
Not many people like the smell, but
so is that the one with the sulfur compounds?
Yeah.
Yeah, it gives it the strong aroma.
Yeah. Strong in aroma. Yes.
Now is the season for mango. A lot of varieties of mango.
Yeah. Now I'd like to see mangoes studied for the, the volatile fraction, because I love the aroma of mangoes. I think they're pretty high in monoterpenes. So that would be an interesting one to study for sure.
Yeah.
What about Java plum, Dr. Listerio? Does the Java plum have strong aroma?
Plum, yeah. Java plum, yes. Yeah. But not as big as mango, maybe.
Yeah.
Yeah.
Okay,
so there's. Oh, you're welcome. Any other questions?
We have another question from Henok Christian, I think. Thank you, Mr. From Henok. The question is how the prospect of phenolic compounds from the berries to against this COVID-19, because I think the most effect in patient is inflammation phase on lung cells. Thank you.
Okay.
I mean, asking about this.
I wish I could say that the berry volatiles would help protect against these viruses. Theoretically, you think they might do some good because a lot of these volatile compounds, when we chew or masticate, a lot of them are going directly from the nose into the lungs. You know, whether they could do this, who knows? That would certainly be an interesting study to do with animals to see if you would get any protection against some of these viruses and the inflammation in the lungs that's associated with these virus infections like COVID. Now, after saying that, you need to be careful because there's some literature that says some of the volatile organic compounds can actually, you know, be damaging to the lung. It depends on the concentration. I think that's what's beautiful about these berry volatiles. It's such a low concentration. I don't think we have to worry about any toxicity. Okay, but if you started using a high concentration, then that might cause problems, you know, with the lungs. I think that's human nature is when we say, oh, something is health promoting at this concentration. Well, let's try more. Let's make a dietary supplement that has 10, 20 times. And that might not be a good idea because that could then potentially be toxic. But yeah, long term, I mean, once we get research, I'd be wonderful if we could get some anti-inflammatory effects in the lungs. One of my colleagues, Dr. Lee, her student is using a cell culture lung model in her research now to see if these volatile compounds do inhibit production of inflammatory cytokines using a lung model rather than the raw cells.
Does it answer your question, Mr. Hanno Christian?
Okay, thank you.
Okay, thank you. Okay, he said thank you, Mr.
Oh, you're welcome.
Okay. Any other questions? Okay, I will ask again. Is that fine? If it's that's fine, I think I will ask you because the volatile compounds is, I think it's not. It's very like easy to vapor, right? And if you add it in the water or any food, is that, I mean, can you still protect the concentration and the benefits?
No, it's a great question. Since they have the high vapor pressure, they're easily going to vaporize, especially when exposed to heat. So, and even, you know, in solution in water, if it's not sealed, yeah, some of these compounds you're going to lose them due to vaporization. But a lot of them do survive. For example, when we pasteurize berry juices, you know, it still smells like the berry. So sure, you lose some, but there's still a lot retained too. But yeah, a lot of these compounds are pretty non-polar. So that might be an advantage too, compared to the phenolic compounds that are more polar, is that these non-polar compounds may have a higher affinity to interact with membranes, okay, than phenolic compounds. But no, the volatility is certainly a concern because, yeah, you will lose them over time.
Okay, because we are here is like tropical country.
Yeah, and the temperature. But hey, you know, if it's a fresh fruit, they're being retained. But yeah, once you start chopping up the fruit, then yeah, well, and you can smell it right with your nose. So yeah, you're getting vaporization of those compounds. But a lot of them are still well retained.
Yeah, and you said also that only small amounts. It's also already have a high effect in inhibit the inflammatory, right?
Definitely. Yeah, it doesn't take much for sure. I mean, so they're definitely, I mean, they're so much more bioactive than the phenolic compounds. If they're 300 to 1,000 times less concentrated in the fruit, and they're showing comparable anti-inflammatory activity, it means they really have potent, anti-inflammatory activity. The thing we have to prove is that they're absorbed in the body, okay, and do the same thing in the body. If not, that's the problem with cell culture assays. It's only a start.
But actually, I think there are many research that also try to encapsulate the bioactive compound. They're
Right.
like nanotechnology. They are, I think, it's now a trend, right?
Oh yeah, definitely. Everybody's trying to encapsulate like turmeric, resveratrol, and we need that because the absorption of these compounds is very low. Even the anthocyanin pigments, the absorption, the amounts that we detect in the urine or plasma are generally like 0.1% of what's ingested. I mean, so that's terrible absorption.
Yeah.
But a lot of these compounds too, if they go to the colon and they can modulate the microbiota, in our gut, that could certainly have a beneficial effect as well on health.
So it varies a lot.
Yeah, sure does. But no, there's a lot of exciting research going on encapsulation nanotechnology in order to improve the bioavailability of these bioactive compounds.
Okay, any questions from the audience? We still have a lot of time, I think.
Can the
From the-
audience ask in bahasa? And Mrs. Karina translate it.
We try to translate as the best as best as I could.
Ya, teman-teman bisa bertanya di dalam bahasa Indonesia. Kalau misalnya,
maybe just write down in our language, so maybe it's much better. I think they have a lot of questions, but they are not a little bit shy. Yeah.
That's fine. That have them type the questions, so you can do it anonymously.
Pak Pulung, tolong ditanya.
silakan Bapak Ibu sekalian, apabila ingin bertanya dalam bahasa, nanti kami akan membantu in English. Silakan. Rindu, kamu Mbak tahu bertanya, Rindu? Francis? Rindu?
Iya Pak, belum ada Pak, masih diskusi sama Titan Pak.
Ayo bertanya. Sir, why you choose blackberry, sir? Why you choose blackberry for your research? For your focus research?
Yeah, good question. There's a lot of berries. Why blackberries? It's because blackberries are important to the state of Arkansas. We have the famous blackberry breeder here at the University of Arkansas, Dr. John Clark.
Wow.
So our administrators always want us to use our locally grown berries to show health benefits, right? Because that helps them promote their berries. So that's really why we use blackberries. But we've seen this effect. I mentioned the study that Dr. Lee students use blackberries, blueberries, strawberries, red raspberries, black raspberries, cranberries. All the berry volatiles work, prevent inflammation in cell culture that we've seen so far. So I don't think it matters what berry type you use, that you're probably going to see anti-inflammatory activity. Because that's something people always ask me, what's the best berry to eat for health? And that's an easy answer. I say eat any berry. Each one has different polyphenolic compounds, different volatile compounds. Eat a wide variety of berries. Americans are bad about this. They hear a study about cranberries are good for you, so they just want to eat all cranberries. So no, you just eat a wide variety of berries. They're all good and healthful. Plus, they all taste different.
Thank you. Silakan teman-teman, Bapak Ibu sekalian, apabila mau bertanya. Sudah selesai belum? Rindu diskusinya?
Belum, Pak.
Maybe I would like to ask a question. Which one is more difficult to measure the volatile of berry and maybe like mango, Dr. Howard? Because I think if like mango or and durian, we can smell the aroma without it, the fruit. But if berry, I think like Java plum, I only can feel the aroma or volatile when we eat like that.
Right, when you masticate. Yeah, you'll certainly see a wide variation in volatile content among different fruit. To me, mangoes are very aromatic. I mean, I love I would think mangoes have a very high volatile concentration compared to other fruit because they're very aromatic. However, again, in our study, even though the 3 varieties of blackberries varied almost threefold in total volatiles, they all showed comparable ability to inhibit the inflammatory cytokines. So it may be that even though your Java plum doesn't have a real strong aroma, I mean, the volatile fraction from that fruit might also have anti-inflammatory activity.
Yeah. Okay.
But I suspect mangoes would work quite well.
Maybe someday you can come to Indonesia and we make research.
Yeah, I'd love to come and eat some mangoes for sure. After COVID.
After COVID, yeah.
Yeah.
I'm sorry, sir. There is a question from Mr. Chris.
Okay.
I will read for you. Is there any specific berry that you use in your research? Maybe specific species of the berries or something else? That's the question. So.
Specific species of berries, yes. or
yeah,
meaning a variety or actual species. I mean, so we've used a wide range of berries in our studies, and I mean, they all have a different anthocyanin profile, phenolic, polyphenol profiles, and volatile profiles. We've mostly worked with blueberries and blackberries, although recently we've done the studies on cranberries, because cranberries aren't grown in Arkansas. They're only grown up north in Wisconsin or out on the East Coast, Massachusetts. But no, we've worked with we worked with chokeberries before as well, or aronia berries. So you can't go wrong with any berry because they're all high in antioxidants, and with the volatile fractions that, they're also going to have anti-inflammatory activity as well. I mean, personally, from a flavor standpoint, I really like blueberries. I think they have a great flavor. And I think most US consumers, prefer blueberries compared to blackberries.
Okay. Okay, there is a question from Mrs. Ariani. Grapes, blackcurrant, and strawberry, is there good on inflammatory content, sir? Is there
for grapes?
Grapes, blackcurrant.
Yeah.
Is there a good content for anti-inflammatory too, or so-so, just so-so?
Well, we haven't measured grapes, but grapes have, you know, a pretty good profile of monoterpenes. So I would think they would work quite well. But to be quite, that's one of the fruits we have not measured yet, is grapes, the volatile fraction versus the phenolic fraction. So that's a good study for someone else to do.
That's enough, Mrs. Aryani, for the question from Mr. Luke, or maybe you want more explanation? Okay, thank you. Enough, sir.
Yeah, you know, because people have looked at the volatile composition of a number of different species of grapes, but nobody that I'm aware of has ever looked at the anti-inflammatory activity of the volatile fraction. They've probably done that with the phenolic fraction from grapes. I mean, we've known from the past 15, 20 years that the phenolic fractions from fruits possess anti-inflammatory activity, but nobody's looked at the volatile fraction.
Okay, sir. Thank you. Silakan teman-teman, ada yang mau bertanya di sini? Bu Monika, Pak Monang, Bu Sarlina yang mengampu pangan fungsional mungkin. Mrs. Sarlina, functional food lecturer. Maybe you can ask some question. Is there any questions, ladies and gentlemen? Okay.
Bu Monik mungkin yang mengajar flavor.
That's fine if you run out of questions, because I got to go teach in 10 minutes.
Okay. I think so. Yeah, I think we are run out of the questions. I think we can, yeah, there's enough. Okay, thank you very much, Dr. Howard. I hope all, thank you very much for these interesting topics for me, and I think for also the audience. I mean, they are lacking, maybe they are, yeah, as I mentioned, maybe they are too shy to ask.
Oh, that's normal. No,
Yeah.
Thank you for inviting me. It's been a pleasure.
I mean, this is the first time for the international, seminars in English with the also from the native one from Indonesia. So yeah, it's very for us. It's a great honor to have you here. So before concluding, I think I would like to have some conclusions. So correct me if I'm wrong, but so far I catch that they are flavonoids, and also the other one is the volatile compound. And actually the volatile compound, even in the small quantity, small concentration, they have the same effect. They have same effect in inhibiting the inflammatory that occurs from your culture cell, like the nitric oxide, and I think there are two different methods that you use.
Right. I'll say that's the take-home message. You've got it, Karina. Even though they're present at a much lower concentration, they have comparable or better anti-inflammatory activity than the phenolics.
Mm-hmm.
Yep.
And you have challenging issues like bioavailability, and also maybe the mechanism of the way the inflammatory mechanism from both compounds. I mean, the phenolics and the volatiles.
Correct.
Okay.
You got it.
Okay. I think now we finally come to the end of this webinar, and I would like to thank you again, Dr. Howard. Hope you can still have sometimes, and maybe next time, or maybe after the COVID, you can come to visit Indonesia. And so I would like to ask all the audience to give a big applause for our speaker. Thank you so much. And
Thank you.
yeah,
And thank you to the singers. The singers were outstanding.
yeah, that is the hymns of our Satya Wacana University. Okay, finally, I would like to thank you, and we hope to see you again. All the participants, thank you for joining us, and thank you so much for the Dr. Howard. It's
Yeah,
really
thank you for inviting me. I enjoyed it.
Okay.
Thank you, sir.
And yeah, have a good day.
Have
You
a
too.
good day.
All right, bye-bye. Bye,
Yeah,
Dr.
thank you, Mr.
Listerio.
Thank you, thank you.
Yeah. Thank you.
Thank you. Bye-bye.
Bye-bye.
Okay, this is the end of our conference. Ladies and gentlemen, thank you. Okay, let's pray for ending this conference. I will lead the ending pray. Let's go. Let's pray together.
Excuse me, Mr. Pulung.
Yeah.
Before we close, maybe remind for all participants to don't forget to fill in the evaluation form.
Please fill the attendance form, guys.
Evaluation form, sir.
Huh?
Evaluation.
I'm sorry?
Evaluation form.
Oh yeah. Attendance form. In the column chat, yeah?
Yeah,
chat,
evaluation form. Evaluation form.
Evaluation form. Okay. You can, before you leave the room, you can fill the evaluation form first, and then you can leave now. Before we ending the conference, we pray together. Okay. I will pray. Dear Lord, thank you for your blessing to the conference that you always with me for us from start to the end of the conference. And after this, we will continue our activity and get some rest and prepare for activity tomorrow. Give bless to Mr. Luke Howard for his healthiness and career and for his activity after this. Thank you, Jesus, for your blessing. Amen. Okay,
Amen.
guys, thank you. Don't forget to fill the evaluation, link evaluation that you can read and in the chat room. Thank you. Thank you, Mr. Chris.
Okay, thank you very much.
Okay.
Yes.
Thank you, everyone.
What is the least satisfied?